It was the 1980s. Scientists stared at the sky and saw a hole. Not a metaphorical one, a real one, a wound in the atmosphere itself. A hole so vast it often exceeded the area of the continental United States at its seasonal peak, at times rivaling the scale of North America. Headlines blared, classrooms warned, and for once the fear felt earned. Some said the sun itself had turned against us. Others whispered that the sky was thinning and that our inventions were to blame. Governments convened, industries bristled, scientists pleaded. And then, the data started to change. But what really happened to the ozone layer? Did it close? Did it heal? Or did we simply stop looking? Today, we're going to find out.
Good evening. Scientists are sounding the alarm tonight. A massive hole has been discovered in the Earth's ozone layer above Antarctica.
An environmental emergency may be unfolding above our heads. Scientists studying the stratosphere report that the ozone layer. Researchers are raising concerns about the depletion of the Earth's ozone layer. Measurements show that a significant portion of this protective shield is...
It began with a mystery no one wanted to believe. In the mid-1970s, two chemists, Sherwood Rowland and Mario Molina, traced a nightmare, that common refrigerants and propellants might be drifting skyward and tearing at an invisible shield, the ozone layer. Ozone, a thin veil of molecules, only millimeters thick if compressed, guarding life against ultraviolet radiation. Without it, the world we know would blister and burn. The culprits, chlorofluorocarbons. Stable down here, but under harsh sunlight aloft they split, freeing chlorine that can catalytically erase many thousands of ozone molecules. Industry scoffed. Politicians hesitated. The chemistry was correct, but the sky seemed fine. Then, in 1985, at a lonely British Antarctic research station, spring arrived, and ozone levels plunged. They recalibrated, rechecked, repeated. The instruments were not broken. The sky was. An ozone hole appeared each Antarctic spring, vast, recurrent, undeniable. And the world could no longer look away. CFCs were everywhere, in homes, cars, hospitals, and factories. To stop the sky from thinning meant reinventing modern life. In 1987, nations met in Montreal and did something history had never seen. They agreed, together, to phase out the very chemicals driving the damage. The Montreal Protocol was born. Over time, every country on Earth joined, making it the first universally ratified treaty in UN history. With financing, technology transfer, and adaptive timetables, the world moved away from ozone-depleting substances. More than 99% of controlled chemicals phased out. It was a bet on science, solidarity, and patience. But even as factories changed and aerosols vanished, there was a catch. The chemicals already released would haunt the air for decades. The wound might reopen every year before it could scar over. You do not fix the sky in a season. In the 1990s, the freefall slowed. In the 2000s, the first hints of a turn appeared. In the 2010s, the trend toward recovery grew clearer, with bumps from natural variability and the occasional outsized year. Scientists kept watch. Instruments orbited and hummed. Models sharpened. Year after year, the picture came into focus. But the answer, the one everyone asked, stayed just out of reach on purpose. Because the only way to know if the sky would mend was to wait. And in the waiting, something else emerged, a blueprint. Why did this story fade from memory? Perhaps because good news is quiet. Perhaps because other crises grew louder. But inside the ozone story is a map with 3 landmarks. Science, say what is true, measure what matters, and keep measuring. Solidarity, act together, fund the transition, and adjust when reality demands it. Patience, accept that atmospheric chemistry keeps its own time. The Montreal Protocol did all 3 and kept every nation at the table. It even expanded. The Kigali Amendment targeted HFCs, not ozone eaters, but potent greenhouse gases, adding climate benefits without sacrificing ozone gains. There were stumbles. unreported CFC11 emissions surfaced in the 2010s, likely nudging recovery by a few years until enforcement tightened. Some recent Antarctic seasons were unusually large or persistent, shaped by stratospheric dynamics and rare events. Yet the long arc remained. The map held. The question lingered. You've waited long enough for the answer. So, what happened to the ozone layer? It is not fully healed, but it is healing, steadily, measurably, globally. Under current policies, the ozone layer is expected to return to 1980 levels by about the 2040s across most latitudes, around 2045 over the Arctic, and around 2066 above Antarctica, with natural ups and downs along the way. Seasonal holes over Antarctica will still appear for years, sometimes larger, sometimes smaller, shaped by the stratosphere's wild weather, but the long-term trend points upward. And that is the quiet miracle. The world reversed a planetary crisis, not overnight, not perfectly, but enough to change the outcome. Remember what arches above you, a shield once damaged by our inventions, now mending because the world chose to act. Science named the danger. Nations made a plan. People adapted. Time did the rest. And the lesson waits in the clear daylight. If we could help the sky heal once, we can do it again. If you enjoyed this video, don't forget to like and subscribe to our channel so you never miss the next story. Thanks for watching.